The purpose of this lab is to learn how to set up a data acquisition card. This is an external data acquisition card from National Instruments that connects to the computer using a USB connection. We will acquire that signal using National Instruments software LabVIEW, and we will be acquiring a function generator signal, and we will use LabVIEW to control the data acquisition card and change the sampling rate to determine the effects of aliasing. And after that, we will also sample a signal from stereo and see the effects of sampling frequency on the sound quality of the music. To connect the USB data acquisition card, simply take the USB connector, insert it into a USB port, and at that time the green button should be blinking. And to connect the analog signal to the data acquisition card, that's done through these screw terminals. For the first part of the lab, we will be using a signal from a function generator. So we have these wires which we simply just connect to the USB card. And now we are ready to create a software program to acquire the analog signal. Well, to create the LabVIEW program, we first open LabVIEW. Then we click on Blank VI, and two windows come up, a block diagram window where you create your block diagram, and the front panel window where it's kind of like the user interface to your program. To create the block diagram, we go to the Functions palette, open up the appropriate menu. Here we're going to select the DAC Assistant block, and then a window pops up. You can select analog input, the voltage, and at this point it recognizes the USB device that you have connected, and it'll let you choose which channel you want to measure. And then another window comes up to be able to change things such as the maximum and minimum voltage range that you can measure. This particular DAC card has different modes that you can select, and how you want to specify the sampling, or if you want to trigger it, or anything like that. Okay, one way of specifying the number of samples and the sample rate is to specify controls, which you can control using the front panel window. To do that, you can just right-click and select Controls. I'll do that for the rate, sampling rate as well. Okay. Now you can see that the number of samples control and the rate control appear in the front panel window. And now I'm just going to add a waveform graph so that we can visualize the waveform. Notice that that appears in the block diagram as well. Now we can connect the output to the waveform block. And this is a complete block diagram. The DAC Assistant will acquire an analog signal according to the number of samples that you set and the sampling rate that you set, and then it will display the digitized signal on this graph. The analog signal that we're outputting from the function generator is a sine wave at 100 Hertz with a 4-volt peak-to-peak amplitude. So I've set the sampling rate to 90 Hertz and the number of samples to 5. That will display 4 periods of our 100 Hertz input signal. And we simply click the Run button to display it. You can see that this looks nothing like 4 periods of a sine wave, because we're sampling a very low frequency. You can try sampling at the Nyquist frequency, which is twice the maximum input frequency, so it's 200 Hertz. And to get 4 periods of the input frequency, we need to take 9 samples. So every time I click the Run button, it's starting the sample at a different point in the waveform, so the amplitude changes. Although we're still getting the frequency content, we're not getting the amplitude content. Sample at a higher frequency, I'll try a sampling rate of 2000, which is 10 times the Nyquist frequency. And to get 4 periods of the input, we need 81 samples. If I run it again. Now the shape of the waveform is looking much more similar to the actual shape of the waveform. Now we're going to investigate the effect of sampling rate on sampling a musical signal. So to do that, we've disconnected the stereo amplifier that goes to the speaker, and we're going to connect that directly into the data acquisition card. To have LabVIEW play the musical waveform, we select the Play Waveform block, which is in the Functions palette, Programming, Graphics and Sound, Output. We just click and drag, and then a window pops up, and this will just select your default computer sound card. Just click OK, and then you just need to connect the input, the Play Waveform block, to the digitized waveform. Now LabVIEW is ready to play the waveform. Most humans can hear about 10 to 20 kilohertz range, so if we sample at about 40 kilohertz, then we should capture everything we need to in the signal, and the music should sound really good. So what we did was we were sampling 10 seconds of music, and so it took 10 seconds for the data acquisition card to acquire that signal, and then after that was done, it played the waveform back for 10 seconds. Now we're going to sample at 10,000 hertz. Alright, sampling at 10,000 hertz, the music still sounded pretty good, meaning that the frequencies are much lower than the highest frequencies a human can hear. Now we're going to sample at 8,000 hertz. Sampling at 8,000 hertz, the signal still sounds pretty good, but you can start to hear a little bit of static in the background. Now we'll sample at 2,000 hertz. Sampling at 2,000 hertz, the music becomes noticeably bad and the high frequency signals get distorted, similar to what you might hear in like a very cheap audio device or a video game. So now we're going to sample at 500 hertz, which would capture only the very low frequencies. Sampling at 500 hertz, all you can really hear is the very low bass rhythm of the music.